All right, back to these pathways problems. We're going to do 1.58. This problem asks us to complete 3 different calculations and report the answer of the computation to the correct number of significant figures. This type of problem has, there's several examples of these in your book. It can also show up on an exam, but more generally, it's something that we want to learn how to do because, again, when we make measurements in the lab, that singular measurement doesn't usually exist in isolation from the rest of the world, right? We usually take that number and we need to perform a computation on it. Maybe we add it to something else, maybe we divide or multiply it, but there's generally some kind of computation involved. So because of that, we really want to pay attention to these rules for how to report sig figs of calculations, okay? And this problem is really nice at guiding us through that. It shows a couple different examples that shows a lot of the rules, and that's why I chose to do it. There are more problems in the book around 1.58 that you can choose to work on your own to sort of perfect your skill at this, okay? All right, so let's just kind of dive in and try to do our best with this, all right? A, there's a 3-part problem. The letter A is this computation. So there's a series of numbers, 3 numbers. We multiply 2 in the numerator of a fraction, and then we divide by 6.48. These are all in meters units, so they have common units. So it looks like our answer will ultimately also be in meters units, okay? Because you had the meters squared here by the multiplication divided by meters, and you get back to meters, okay? So how in the world are we going to do this? Well, what I would like you to do to work these problems is to basically go ahead and work the math on your calculator at first. So what that means is take this, multiply it by this, take that result and divide it by 6.48. Okay, and if you go ahead and do that, what you'll get on your calculator, or at least what I got, was 1.3371142. Now, does this mean that that's our answer? That we're going to stop there and not do anything else? Absolutely not. This is just what your calculator reads. We have not done anything at this point to pay attention to significant figures at all. And we need to do that if we're going to get this question correct, okay? So how in the world do we do that? Well, what we need to do is review in our book and from our lecture the rules for propagating sig figs through calculations. There are different rules for different calculations or different types of calculations. So for instance, I'm familiar with the rule for multiplication and division. This particular computation only involved multiplication and division. And fortunately, the rule for multiplication and division is identical. They are the same. What we need to do to propagate sig figs for computations involving only multiplication and division is we compute our answer from the calculator, and then we truncate that, or we limit the number of digits such that our answer contains the same number of significant figures as the least precisely known value that we've used in the computation. All right, so for what that means here, or how we're going to figure that out, we're going to go back to the original numbers that we used and figure out how many sig figs are reflected in each of the values. So here, there's 4 sig figs. This one's only got, 3? Because this 0 counts. It's to the right of a non-zero number and a decimal point. And this one's got 3. So the least precisely known value of our input values is 3 sig figs. That means that following this rule, our answer also needs to have 3 sig figs, because the rule for multiplication division is your answer should have no more or no fewer sig figs than the least precisely known value. Okay? So looking at this then, I say, okay, 1.33, this is my 3rd significant digit, but since this is a 7, I'm going to have to round that 3 up to a 4. As a consequence of the sig fig rule, I should report my answer to this computation as 1.34 meters. It's got 3 sig figs, the same as the least precisely known value in the numbers that I'm combining. Okay, so moving on then to letter B. All right. In B, they give us this formula for the volume, 4/3 pi r cubed, and they tell us that the r is 17.282 millimeters. Compute the answer to the correct number of sig figs. Okay, so let's think about this. This one's got a little bit of a different thing going on. For one, we've got this fraction here, and then we've got this value of pi. Everybody knows pi, right? So right about 3.14. I'm going to write a few more digits here. I'll explain why I do that in a second, okay? I actually went ahead and looked these up just for the purpose of this problem. But of course, pi goes on and on and on, many, many digits. You've probably heard that story before. And then we got to multiply by the radius cubed. So 17.282 millimeters. The units here. We're going to cube that, okay? So those are the numbers that we're working with. Now again, how do we do this? The first thing you need to do is identify what type of math operation you're working with. Is it multiplication and division or addition and subtraction? Again, here we only have multiplication and division. All right, that's nice because the rule for multiplication and division is the same. It's the same rule we used up here in A. So again, what I'm going to encourage you to do in such a case is go ahead and work out the math on your calculator, just as you normally would. Multiply and divide things together, as you need to do to get a numerical answer. And then once you finish that and you have a numerical answer, we come back and we think about sig figs at the end. Now in this particular case, when I do that computation, I get 21,620.7429 cubic millimeters would be the answer that I get off the calculator. But I have not done anything to think about sig figs. And that's not going to be correct if I'm considering sig figs. And the reason why is because I have to honor the rules again. Okay? Now what was the rule for multiplication and division? It was to look at the numbers that are used to generate your answer. And your answer should have no more or no fewer sig figs than the least precisely known variable or value. In other words, you want the same number of sig figs in your answer as the least precisely known number up here. Okay. All right. So then we have to ask ourselves, okay, well, what about these numbers, right? How many sig figs? Okay, so let's start on the right. 17.282. Okay, that's easy. That one's got 5 sig figs. Right? It's pretty easy to figure out. There's 5 sig figs there. And then I wrote this value for pi here. How many sig figs? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 is what I've written. Okay, there could be more if I really worked at it. Okay, and then we've got this one. 4/3. 4 divided by 3. 2 integers divided by one another. Okay, this is integers are counting numbers. They're kind of exact, right? So it's not even a measured value, it's 3 or 4. It's an exact integer value. Because of that, they're considered to essentially have infinite sig figs. Okay, so that's not going to limit us. So what does limit us then is the 5 that's reflected in our measurement. Now, remember I took so much care to write out all these decimal digits here when I was working this problem before? Why did I do that? What if I would have only stopped with 3.14. Well then, that number of 3 sig figs would have limited how many I can report in my result. And because I like to report my result with as much precision as possible, I took actually additional time to write out more sig figs here because going into this problem, I knew that it would limit my answer if I didn't do that. All right, so that's why I took all this trouble and wrote out more sig figs here. But now I created a situation because I knew that this was precisely known to many, many digits. I created a situation where my measured variable, my r, is what limits the precision of my result. So sure enough, my answer should have 5 sig figs. And it looks like that's going to occur essentially right here. And because this is a 7, I need to round up to a 1. The 0 becomes a 1. And my answer should be 21,621 cubic millimeters, okay? All right, moving on then to the last problem here. I'm going to draw a line across here so we can talk about C down here at the bottom of the whiteboard, okay? In C, we're going to add four numbers together. The first number is 1.110 centimeters, and we're going to add 17.3 to that, 108.2, and 316. Now, one thing I kind of want to warn you about, your book was not trying to be tricky when they put together this particular problem, but what I would like you to be real careful about here is if I wanted to be tricky with this problem, or if your book wanted to be tricky, I might ask you to add numbers that have different units, and maybe you have to do a unit conversion before you add. Fortunately, that was not done here. But be real careful that you don't get in a hurry with these problems and try to add dissimilar numbers or numbers with different units, because that's not going to work out well for you, okay? But here it's all centimeters, which is really nice. It's common units, we can just add these numbers together. So how in the world do we approach this? Well, just like before, what I'm going to encourage you to do is add together all of your values on your calculator. Now, if you do that, you get 442.61 centimeters. Now, is that our final answer? No, it's not, because again, we have not considered the effect of significant figures on this value, or how many sig figs we should report. Now, this computation is very different than the ones we talked about so far. And the reason why, of course, is this is an addition operation. The rules for addition and subtraction are not the same as the rule for multiplication and division. It's a completely different rule that you've got to honor. The sig fig rule for computations involving additions or subtractions is that your answer should have the same number of decimal digits or decimal places as the least precisely known value. Okay, that's kind of a mouthful, but reason your way through it. Your answer should have the same number of decimal digits as the least precise known value that you're adding or subtracting. So how does that work in practice? Okay. Well, this number, it's pretty precise. It's actually got 3 digits of precision to the right of the decimal place. The 1, the 0. 3 digits. This number is less precisely known. Only 1 digit to the right, as is this one. And then lastly, over here, I've just got 316 centimeters. There's no decimal digits of precision here at all, right? It's just 316. So it's about 316 is what they're trying to communicate to you. So what that means then, what that means to us, is that our answer should be reported as 443 after rounding up. My answer can't have any decimal digits because my least precisely known variable has none. So that's honoring the rule for addition and subtraction. And this is what we should report as our final answer.